This is part 3 of the series of the building of the Liebherr LTM 1750 mobile crane. In the last part we saw that the manual recommended we needed to trim some parts to make some gears run smoothly, and that perhaps wasn't the nicest way to put together a model using a Technic type system. Still, we did try it, but since the last video, the model maker has come up with some revised instructions to do away with the clashing parts. So here we have some revised instruction sheets, and they substitute the larger gear wheel for 2 smaller ones. So what we'll do is we'll implement the changes, but I'm not sure how that will leave us at the end, because by changing some parts maybe we'll not have enough of some of those that we need. Anyway, we will press on, and here you can see where the substitution has been made with the 2 small gear wheels instead of 1 big one. The maker has also sent some universal joints because there were not enough in the box. With those changes, the build has continued, and here we have the carrier in its current state. As you can see, it now looks much closer to the real crane because it's had its wheels fitted, and it's worth saying that some of the stages are a complicated build. The driving cab is fitted onto the front of the carrier, and here the 2 instruction books were in conflict about how it fits. It is hard to fit, and we had to make a few small changes to get it to look right. Moving on, we've located a position for the power pack, and we've tried to sort out some of the power leads from the motors to run to it. Also fitted are the hydraulic rams which control the fold-out movement of the front outriggers, and we've also fitted the hydraulic rams for the rear outriggers. The Outrigger Beams were made in the previous episode, and here you can see the attachment points for them. Above that is the lower slewing ring for the crane. To help it run smoothly, it needs some rollers, and the model comes with these small red circles which fit into the slewing ring. Here we're adding in just a few, but in fact there's a whole bag full, and you can see how they work by adding in the ring from the top part of the crane. That sits on the top of the rollers, and then when the crane turns, the whole thing moves nice and smoothly. Before we go any further, let's test what we've built so far. And to do that, we'll connect up some of the electrics. And then using the remote control, we can do some system checks. And the first one is the steering, which seems to work fine on the front 5 axles. But in fact, it also should work on the rear 2 axles. So there's a problem in the mechanics that we'll need to sort out. Hopefully it's just a loose connection in one of the drive shafts. Next, we'll do a check on the driving wheels, and unfortunately this has a rather different problem. The front wheels are turning in one direction, and the rear wheels are turning in the opposite direction. So we'll have to investigate and find a solution to that problem. And to prove life is not trouble-free, the engine also appears to be not properly connected. To correct the drive wheels, the solution was to reverse the gearing on 2 of the axles, although I'm not really sure why this problem happened. But rather than waste time investigating, the solution was fairly simple. So with the gearing corrected, it's possible to drive the carrier along. You have a choice of 2 speeds, and that's forwards or backwards, and the unloaded carrier moves well enough. Let's now try out the steering, and that works well enough on the front axles, although the motors would perform better if the carrier was actually moving along. Because this is a plastic model, there is some flexing of the parts, and as you can see, the carrier is not very rigid. With that said, it all adds up sometimes to moving parts not moving as well as they might. And as you can see here, it's easy for a steering rack to become disengaged. The flexibility in the structure also appeared to be the root cause of the steering not working properly on the rear 2 axles. So I've made a small modification which helps keep the drive axle for the steering in place. And with that done, although the rear steering is straining a bit, it does now work. So we've corrected the steering and we've got all of the drive axles working in the same direction. And that left one other issue to fix, which was the engine. The cause was a loose connection, and with that corrected, the engine now works too. Moving on, we previously made and tested the Outrigger Beams, and now we can fit them onto their connection points. The instructions for doing this are not at all clear, and it is a tricky little operation to fit the Outrigger Beams properly. Once they're in place, we can then connect up the hydraulic rams that control them, and here you can see that the folding mechanism is controlled by a motor. But again, the mechanics here are on the limits of the system, so the operation is not flawless. At this point, it is worth saying that this is a very complex model, and the instructions are not the easiest to follow because some of them are too small. It's also frustrating that some parts, such as the beams, are not given sizes, so you have to keep counting the holes to make sure you've got the right size. Also, the manual doesn't help with the routing of all the cables, and there are quite a lot of them, so we'll have to see how that works out as the model progresses. In the meantime, we've progressed with some other parts of the build, and here is the main counterweight tray. And as you can see here, the winch is controlled by a turning handle rather than a motor. The counterweight blocks are made up of fabricated parts, and there are 2 parts, and this is one of them. They look okay, but of course they are very light, and the manual does tell you that you need to put some weight inside them to provide a proper counterweight. The counterweight blocks fit onto the tray, although for the moment we won't fix them on fully. Another part we've made is described as a hoisting box, and it appears to be a load box that we can hang from the hook, and it has opening sides. Another part we've made is the crane cab, and this is quite a good looking representation. It has a moving seat back, and there are 2 big levers inside, although I'm sure the real crane doesn't actually have those. It's nice that the cab has got handrails outside. Next we have the first part of the telescopic boom, and this is a very large piece. It's got a nice looking shape and it's quite solid when it's put together, and this is only the outer part of the telescope. It has a motor installed at one end, so before we go any further we'll test that out to make sure that works. And as you can see, it drives an axle that runs along the length of the underside of the boom. At the other end there are 2 worm gears, and they will be used to push out the inner telescope. Here's a look in through the end of the telescope, and hopefully in the next part of this series we'll see the whole model complete.